Hi, in this video, we will be seeing some concepts based on section 8.3, which involves applications to physics and engineering. In section 8.1 and 8.2, we saw some applications of integrals in finding the arc length and surface area. In Calc 1 classes, you've already seen some other applications of integrals to find the area between two curves or to find the volume of revolution of solid using washer method, disk method, and cylindrical shells method, and so on. So here you have a thin plate and it is submerged in a fluid. The depth above the plate is D. Suppose that a thin horizontal plate with area A square meters is submerged in a fluid of density rho kilograms per cubic meter at a depth D meters below the surface of the fluid as in the figure. The fluid directly above the plate has the volume which is A times D. To see this, if we take a box, rectangular box, let's say, and then if we want to find out the volume of this rectangular box, we know it is L times W times height. The volume of the box is L W height. Length times width times height. Here L times W is nothing but the area of the base multiplied by height. The area of the base is area of the rectangle, which is L times W, and then times height. So in general, it is area of the base, the volume is area of the base multiplied by height. So in this case, that's the same idea we are using here. Volume V is A times D, which is the area of the thin plate multiplied by the height of the depth of the liquid. The mass, we know from physics, is density multiplied by volume. The density is given to be rho kilograms per cubic meter, so rho times V. But V from the previous step is A times D, so we can replace the V from the previous step A times D. So mass is rho times V, but V in turn is A times D from the previous step. So mass becomes rho times A times D. Rho is the density measured in kilograms per cubic meter. A is the area of the plate and D is the depth of the liquid. And the force exerted by the fluid on the plate is therefore mass times acceleration, which is again a formula from physics. Force is mass times acceleration, but mass from the previous step is rho A D, that is the mass, and then times G, that is rho A D G, where G is the acceleration due to gravity. And the pressure on the plate is defined to be the force per unit area. P, pressure, is force multiplied by area, which is rho A D G, which is the numerator force from the previous step, divided by area. So if we cross the area out, then it becomes rho D G. Rho is the density, D is the depth of the liquid, G is the acceleration due to gravity. So that is the pressure formula. Now we have to consider two measures of units. One is the SI unit, which is International System of Units, where the measures are based on kilogram, seconds, and meters. In this system, pressure is measured as newtons per square meter, which is called a Pascal in abbreviation. So 1 Newton per meter square, which is the unit for pressure, The numerator is the force, denominator is the area, that's what we saw here, which is 1 Pascal PA. As this is a small unit, we normally consider the kilopascal, kPa is often used. For instance, because the density of water is rho, which is 1000 kg per meter cube, the pressure at the bottom of a swimming pool 2 meters deep is pressure by the formula that we just did, is rho GD, which is rho is the density of water is 1000 kg per meter cube, multiplied by G, which is 9.8 meter per second square, times depth of the swimming pool, which is the 2 meters here. If you use this 1000 times 9.8 times 2, you get 19,600. The unit for pressure is Pascal, but as this is a huge unit, we divide this by 1000 and we write 19,600 divided by 1000, and we write that in kilopascal, which is 19.6 kilopascal. If this is, but if you're considering US customary units, where the measures are based on foot and lb and then seconds, then we write pressure as pressure, which is rho GD, becomes actually delta D. The rho times G, which is the mass density, becomes a weight density here, delta D, where delta is the rho G, the weight density. For instance, the weight density of water is delta, which is 62.5 lb per feet cube. Here, in summary, I can say force is rho A dg is the formula. Rho is the density, A is the area, D is the depth, G is the acceleration due to gravity. Pressure is rho dg. Rho is the density, D is the depth of the fluid, and G is the acceleration due to gravity. And then if you use that SI system in the US customary units, pressure will become delta D. Instead of mass density, which is rho G, we use the weight density, which is delta, which is rho times G, where delta is taken as 62.5 lb per feet cube, which is the weight density of water. In the case of SI system, where the measures are based on kilograms, meter and second, water density is considered as 1000 kg per meter cube. Hope this video helps, and in the next video I'll be showing you an example.